Hello my dear students, welcome back to NEET WORLD. So today in this session we will be continuing our discussion on chemical kinetics. So in the last session we have discussed what is a use of thermodynamics, equilibrium and the next chemical kinetics. I told you that thermodynamics says about spontaneity, whether a reaction takes place or not, and what are the suitable conditions. The next equilibrium, to what extent a chemical reaction is taking place. Okay, when it comes to chemical kinetics, we discussed that how fast a chemical reaction is taking place. So what is the speed of a chemical reaction, whether it is happening slow or fast. Like this we discussed about chemical kinetics. Now chemical kinetics deals with what? Speed of a chemical reaction. That speed in chemistry terminology we will say in terms of rate of a chemical reaction. So what do we mean by rate of a chemical reaction? With respect to time, how that concentration of reactant is converting into product. అంటే రియాక్షన్ జరుగుతున్న కొద్దీ ఆ రియాక్షన్కి ఎంత టైం పడుతుంది, అలానే టైం అవుతున్న కొద్దీ రియాక్టెంట్ కాన్సంట్రేషన్ ప్రొడక్ట్ లాగా ఎలా మారుతుంది. Okay, or how much amount of product formed, all this will be discussed. Okay, right. So now let me give a quick understanding recap of yesterday's discussion. That I told you there is something called differential rate equation. What is a differential rate expression or equation? Okay, so here today we will be studying about rate law or rate expression. Before coming to this, let me show you the yesterday's discussion. That is for example, there is a reaction like this. There is a reaction like this, A plus B giving rise to C. Okay, so along with there is some coefficients also, like 2, sometimes here 3, sometimes here 2, or maybe some number or something will be there. Right, now those are called stoichiometric coefficients. This 2, 3, 2 are what? Stoichiometric coefficients of those reactants and the product. Okay, now if I ask you to write a differential rate equation, so differential rate expression or equation here, so what you will do is, here these two are reactants and this is product. Right now, so change in the concentration of reactant, that is dA by dt. Okay, so now what happens to concentration of reactant as time goes on? Reactant concentration decreases now, so you can insert a minus symbol. And what is the stoichiometry here? We have 2, so you can write minus 1 by 2 dA by dt, which is equals to, here 3 is there now, so you can write 1 by 3 dB by dt. So what is this square bracket indicating? That indicates change in concentration of B with respect to time. And here you need to take whatever the stoichiometric coefficient that should be in the denominator. Okay, since this is also reactant, use the symbol minus, because concentration of reactant decreases. Okay, which is equals to this change in concentration of product. How can I write? That is dC by dt. Okay, what is this stoichiometric coefficient? Here we have 2, so you write it as 1 by 2. Now since product is forming, you should indicate with a positive symbol. Okay, so this is our differential rate equation. Okay, I hope this is clear. Now for the same reaction we need to write a rate law. What we need to write? Rate law. So what is this rate law? So rate law means how concentration is, how rate is changing, or relation of rate on the concentration of reactant. అంటే ఒక రియాక్షన్ జరుగుతున్నప్పుడు దాని యొక్క స్పీడ్ అనేది దేనిపైన డిపెండ్ అవుతుందంట? ఆ రియాక్షన్లో ఇన్వాల్వ్ అయిన రియాక్టెంట్స్ పైన ఇన్వాల్వ్ అవుతుంది. మళ్ళీ ఒక రియాక్షన్ జరుగుతున్నప్పుడు రేట్ ఆఫ్ దట్ రియాక్షన్, ఇట్ మీన్స్ రియాక్షన్ ఎంత స్పీడ్గా వెళ్తుంది అనేది దేనిపైన డిపెండ్ అవుతుందంట? వాటి యొక్క రియాక్టెంట్స్ పైన డిపెండ్ అవుతుందంట. సో రేట్ ఆఫ్ ఏ రియాక్షన్, దట్ ఈస్ ఆర్, డిపెండ్స్ ఆన్ కాన్సన్ట్రేషన్ ఆఫ్ రియాక్టెంట్స్. What is that? Concentration of reactants. So now what are the reactants? We have A, B are the reactants. So now rate is directly proportional to concentration of A and concentration of B. Okay, and not only this AB, with respect to A there will be some variation, like A to the power m and B to the power n I am writing. Okay, once again, what is this AB indicates? AB are called our reactants. What these are? Reactants. Okay, now what about this m and n? So m and n, this small m and small n are orders. What is that? Orders of reactant A and B. A and B. Okay. Now there is something called order. I will tell you order and enti cheptanu. First just write the thing. Okay. So these are M comma N. So now total order of the reaction, if I ask total order. If I ask, you just add M plus N. That is your total order of the reaction. Ante, for example, konni reactions, some reactions are called as first order. What I am saying? Some reactions are called as first order. So when I say first order, this total M plus N value should be equals to 1. Okay. So M plus N value equals to 1 means either M should be 0 or N should be 0. One should be 0, other one should be 1. ఒకటేమో 0 అవ్వాలి, ఇంకొకటి 1 అవ్వాలి. లేకపోతే M can be half, N also can be half. ఇలా total sum should be equals to 1. That you can say it as a first order reaction. And the next one is second order reaction. So second order reactions means what? The total M plus N value should be equals to 2. It can be any form. M can be equals to 2, N can be 0. This will be 0, this will be 2, or both 1 and 1. Like that it can be any format, but total sum should be 2. That's it. Okay. So now how can we get these values, sir? Yeah, we cannot do them theoretically. మనం థియరిటికల్గా మనకి తెలియదు ఇది. అంటే ఒక రియాక్షన్ చూసి ఇది ఫస్ట్ ఆర్డర్ సెకండ్ ఆర్డర్ అని చెప్పలేం. Okay. So that order of a reaction comes only from experimental data. From where it comes? It comes from experimental data. So sir, how can we know that in the exam? Yeah, they will provide the experimental data and they will ask us to identify which order this reaction is following. By looking at the experimental data, we need to identify whether a reaction following first order, second order, or 0 order, or some other any orders. Okay. Just by looking at the reaction, we cannot give theoretically. It can be purely comes from where? It comes from experimental data. Okay. Right. Yeah. ఇప్పటిదాకా మనం ఏం డిస్కస్ చేసినామో అది అర్థమైంది కదా. యా, లెట్స్ మూవ్ ఫార్వర్డ్ విత్ little more things. See what I told you, rate of a reaction. Let us say this is a reaction. For this reaction, rate of a reaction can be for this reaction, rate of this reaction is directly proportional to concentration of reactants. What are the reactants? A, B are the reactants. So I have written A, B to the power some M I told na, you can put some X also, no issues, to the concentration of B to the power Y. So here what is this X and Y says? X and Y's are called orders with respect to A, order with respect to B. Okay. Now what we will do is, let us remove this proportionality symbol and let us put a constant, that is rate of reaction is equals to K into A to the power X, B to the power Y. ఇలా రాయొచ్చు కదా. జస్ట్ ఐ రిమూవ్డ్ ఏ ప్రపోర్షనాలిటీ బై ఇన్సర్టింగ్ ఏ కాన్స్టాంట్ K. Okay, that is equals to rate of a reaction is equals to K into concentration of A to the power X, B concentration of B to the power Y. ఇలా రాయొచ్చు rate of this reaction. Okay, so K is called what? Proportionality constant or the rate constant you can say. And what is this X and Y? X and Y may be equals to stoichiometric coefficients. Once again look at this. Sir, why you are writing X? You can directly write A now. Yes, sometimes you can write A, but it is not all the times. Okay, so eppudu rayali mari? Yeah, chemical reactions are of two types. What I am saying, chemical reactions are two types. One is called elementary reaction, and the second one is called complex reaction. What is the second one? Complex reaction. Elementary reactions and complex reaction. So elementary reactions are those reactions which takes place in single step. So elementary reactions takes place in single step. How many steps it will take? Single step. Reactions happens in single step. Okay, ఒకటే స్టెప్ లో రియాక్షన్ అయిపోతుందంట. వాటిని ఏమనాలి? ఎలిమెంటరీ రియాక్షన్స్ అనాలి. సో ఇన్ దీస్ ఎలిమెంటరీ రియాక్షన్స్, వాట్ ఎవర్ ద స్టైకియోమెట్రిక్ కోఎఫిషియెంట్స్ ఆర్ దేర్, దోస్ బికమ్ ద ఆర్డర్స్ ఫర్ దోస్ రియాక్టెంట్స్ ఇన్ ద రియాక్షన్. Okay, ante if I say this reaction as elementary reaction, then rate can be written as K, rate equals to K into A to the power small a, concentration of B to the power small b. So what is this A, B is indicating? Orders of the reactions or these reactants. What is the total order if I ask? A plus B, you can say this is the total order. Okay, so this is the scenario only for which reactions? elementary reactions. When it comes to complex reaction ante that happens in multiple steps. అంటే రియాక్షన్ అనేది ఒకే స్టెప్లో జరగకుండా 2-3 స్టెప్స్ అలా మల్టిపుల్ స్టెప్స్ ఇన్వాల్వ్ అవుతాయి. అలాంటి రియాక్షన్స్కి మనం స్టైకియోమెట్రిక్ కోఎఫిషియెంట్స్ని వాటి ఆర్డర్ లాగా కన్సిడర్ చేయకూడదు. సో ఫర్ దిస్ ఫ్రమ్ వేర్ విల్ గెట్ ఫ్రమ్ ద ఎక్స్పెరిమెంటల్ డేటా ఓన్లీ. సో ఈ సింపుల్గా మనం ఏమని అర్థం చేసుకోవాలి, ఆర్డర్ ఆఫ్ రియాక్షన్ కమ్స్ ఫ్రమ్ ఎక్స్పెరిమెంట్ నాట్ థియరిటికల్లీ. అంటే మనం రియాక్షన్ ఇట్లా జస్ట్ థియరిటికల్ బుక్లో చూసి చెప్పలేం, మనకేం కావాలి, ఎక్స్పెరిమెంటల్ డేటా కావాలి అది చెప్పాలంటే, ఆర్డర్ ఆఫ్ రియాక్షన్ చెప్పాలంటే. సో దట్ ఈస్ వాట్ ఫర్ ఎ కాంప్లెక్స్ రియాక్షన్ order can be determined experimental values only, not theoretically. Okay, remember that. Yeah, up to here it is clear na? Yeah, then next, so this is how we have written. So I told you this is called differential equation, rate expression, and this is rate equation, rate law. Okay, right. So the next one, yeah, up to here it is done. Next, so now they will ask you about rate constant. What is that rate constant? I told you, if A, B are combining to form some product, so the rate of reaction depends on concentration of A and concentration of B to the power some numbers will be there, like say M and N are there. Okay, now if I remove this proportionality, I can place a constant here, K. So they are talking about this K now. A power M, B power N is there now. So they are discussing about this K. What is mean by K here? They are asking. So simply you can see the same equation here I have written. So rate is nothing but reactant is converting into product, means rate is nothing but directly proportional to concentration of reactant to the power some coefficient. That is called order. Some number will be there, that is called order. Now from this I want only K. What I can do now? K is equals to rate by concentration of reactant to the power M, whatever the M. అంటే M అంటే ఏంటి, ఆర్డర్ ఆఫ్ దట్ రియాక్షన్ అని గుర్తుపెట్టుకోవాలి. ఓకే, సో నౌ రేట్ యొక్క యూనిట్స్ ఏంటి? ఎస్టర్డే వి డిస్కస్డ్ అబౌట్ రేట్ నా. సో డిఫరెన్షియల్ రేట్ ఈక్వేషన్ ఎస్టర్డే వి డిస్కస్డ్ వాట్ ఐ టోల్డ్ యూ, రేట్ మీన్స్ చేంజ్ ఇన్ కాన్సన్ట్రేషన్ విత్ రెస్పెక్ట్ టు టైం. సో కాన్సన్ట్రేషన్ అంటే ఏంటి, మొలారిటీ కదా. సో మొలారిటీ యూనిట్స్ ఏంటి, మోల్ పర్ లీటర్. వాట్ ఈస్ ద యూనిట్స్ ఫర్ మొలారిటీ, మోల్ పర్ లీటర్. ఓకే, అండ్ వాట్ అబౌట్ temperature, change in temperature means time inverse. You can take like this, mole per liter time inverse, like second inverse, minute inverse will be the units for rate. So దీని యూనిట్స్ వచ్చేసాయి మనకి, న్యూమరేటర్ యొక్క యూనిట్స్ వచ్చినాయి. సో ఐ వాంట్ కంప్లీట్ యూనిట్స్. Here in the numerator, rate units are nothing but mole per liter per second, like time inverse. Okay, what about the denominator? This is square bracket, indicates what I told you in the last classes, like concentration can be indicated with square bracket. So here you can write simply concentration to the power M. So mole to the mole liter inverse means also concentration only. So concentration to the power 1 and denominator concentration to the power M. So వాటిని సింప్లిఫై చేయాలి. ఇప్పుడు మనం లాస్ట్కి ఇలా వచ్చింది చూడండి, రేట్ బై కాన్సన్ట్రేషన్ టు ద పవర్ ఎన్ అని అంటే మనకి ఫైనల్గా ఏమొచ్చింది, యూనిట్స్ ఆఫ్ కే మీన్స్ కే యూనిట్స్ ఆర్ టేకెన్ యాజ్ కాన్సన్ట్రేషన్ టు ద పవర్ 1 టైమ్ ఇన్వర్స్ బై కాన్సన్ట్రేషన్ టు ద పవర్ ఎం. ఓకే, సో నౌ వాట్ ఎవర్ ద థింగ్ ప్రజెంట్ ఇన్ డినామినేటర్ రైట్ ఇన్ ద న్యూమరేటర్. అప్పుడు ఎలా రాయొచ్చు, హౌ కెన్ వి రైట్ దీస్? సో ఎం కెన్ బి రిటన్ అప్ సైడ్ by putting a negative sign like minus m. Okay, ఇది కాన్సంట్రేషన్, ఇది కాన్సంట్రేషన్. Can we write both of them in the numerator? Yes, we can write. Okay, already 1 is there. If I write this plus m in the numerator, it becomes minus m. That is concentration to the power 1 minus m. Okay, multiplied with time inverse. Okay, so this is the units of rate constant. So what is the units of rate constant? Use of rate constants anante, for example, I am saying, yeah, I will give a question. Let us take first order units of rate constant, units of rate constant for first order reaction. Which reaction I am saying? First order reaction. So how you are going to do this? first order reaction means put m value equals to 1. So what happens now? K is equals to concentration to the power 1 minus first order, no? M value is 1. So what is this m indicates? What is the order of the reaction? So I am saying order as 1. 1 minus 1, 0. So time inverse. So finally what we are going to have? Concentration to the power 1 minus 1, 0, na? Something power 0, 1. So into time inverse. So time inverse means finally what is the units for first order rate constant? It is just time inverse, like second inverse or minute inverse or hours inverse. Like this we are going to get our answer in terms of second inverse or minute inverse, hours inverse, like that. Okay, so this is the units for first order rate constant. So now what is the using of understanding of this? Because by just looking at the rate constant units, we can identify which order that particular reaction is following. Okay, now that is why I am saying this is important. Now tell me, what is our general formula we got for rate constant? K is equals to concentration to the power concentration to the power 1 minus m, time inverse we got. So what is this m indicates? Order of the reaction. What is that? Order of reaction. Let us say 0 order reaction. Which order reaction I am saying? 0. It means m equals to 0. It indicates what? 0 order reaction. So now what happens? K will be equals to concentration to the power 1 minus m. 1 minus m means m value is how much? 0, because m indicates order of the reaction. I am saying 0 order. Time inverse. So concentration to the power 1 minus 0 is 1 only. So you are going to get concentration multiplied with time inverse. So concentration units are what? Mole per liter into time inverse. So this is how you need to calculate your final answer. Let us directly write this mole per liter in this bracket itself, so that we can get a generalized formula. See guys, there are many questions asked on the units of rate constants only in NEET, JEE or EPSET exams. Okay, I hope you have followed this session up to here, right? Now K is equals to, in the place of concentration, what I can write? Mole per liter. Mole per liter to the power 1 minus m into time inverse. Okay, like this you can write. Yes. Now let us do it for second order reaction. So K2, second order na, K2 let us say. Mole to the power 1 minus m. M value is second order na 2. Time inverse. So what is this going to be? K2, units of rate constant will be mole. See, 1 minus 2 is minus 1 now. So mole to the power minus 1 liter, already minus 1 into minus 1. So it becomes plus 1. So mole inverse liter into time inverse, like second inverse, minute inverse, like that you are going to get. Okay, you can understand in this way. Now my question for you is, what is our units of rate constant for third order and fourth order reactions. So tell me your answer in the comment box. Units of K for third order, fourth order reactions. Okay, you please mention that in the comment box, then I will see if there is anything to discuss. If there is any mistake, I will be discussing and I will be explaining in the comment section itself. Okay, so feel free to express your doubts in the chat box. Okay, right. Next, this is what we have finally, rate constant, units and all. Next. Okay, now what I told you about the order of the reaction, whatever the power we are seeing, let us say this is a reaction. So when I say rate law, how you are writing? Rate law, R is proportional to concentration of A and concentration of B and C also there. You can write all the reactants like this. Now for each of the reactant there will be some powers. That powers are called like a power x, b power y, c power z are there. So that powers are called orders with respect to each reactants. Okay. So x is an order with respect to a, y is an order with respect to b, z is an order with respect to c. Now total order of the reaction, if I ask, x plus y plus z will be considered as total order of the reaction, total order of the reaction. Okay. So now read this, the power to which the concentration of a species is raised in the rate law is called order of the reaction with respect to that particular species. Simple. Order with respect to A is x, order with respect to B is y. Like that they are defining here. Okay. If I ask total order, you just sum those orders, I mean those powers. Okay. Now what I told you, order of a reaction cannot be given theoretically, it can only comes from experiment. Okay. Now if I know the order of the reaction, I can say how fast the reaction is taking place and what factor it is depending on. It means ఒకటి క్లియర్గా అర్థం చేసుకుందాం. Let us say order with respect to A is 2, order with respect to B is 1. అంటే if you increase the concentration of A 2 times, order becomes 4 times. Once again, if I increase the concentration of 2 times, అంటే దీని యొక్క ఆర్డర్ ఎంత అమ్మా, ఏ యొక్క ఆర్డర్ 2 అని చూస్తున్నాం కదా, సపోజ్ కనుక్కుందాం. ఓకే. ఏ యొక్క కాన్సన్ట్రేషన్ 2 అని అంటున్నాం, బి యొక్క కాన్సన్ట్రేషన్ ఏ యొక్క ఆర్డర్ 2 అని అంటున్నాం, బి యొక్క ఆర్డర్ 1 అని అంటున్నాం. సో వాట్ డస్ ఇట్ సేస్, ఈ ఆర్డర్ వల్ల యూజ్ ఏంటి అని అంటే, లెట్ us say ఐఎమ్ ఇంక్రీజింగ్ ద కాన్సన్ట్రేషన్ ఆఫ్ ఏ 2 times. హౌ మెనీ టైమ్స్ ఐఎమ్ ఇంక్రీజింగ్? 2 times. సో వాట్ హ్యాపెన్స్, ఇట్ బికమ్స్ 2a. సో 2a to the power 2 అంటే ఇంత, 2 to the 4 కదా. సో రేట్ ఇంక్రీజెస్ 4 times. అదే బి మరి, ఇఫ్ ఐ ఇంక్రీజ్ ద కాన్సన్ట్రేషన్ ఆఫ్ బి 2 times, our rate also increases 2 times. But here if I increase the concentration of A 2 times, rate increases 4 times. Why? Because this power 2 is there now. So that's why 2 to the power 2 means 4 it becomes, no? That's why rate becoming 4 times. అలా అర్థం చేసుకోవచ్చు అన్నట్టు. ఏ కాన్సన్ట్రేషన్, ఏ రియాక్టెంట్ యొక్క కాన్సన్ట్రేషన్ ఇంపాక్ట్ ఎక్కువ ఉంది రియాక్షన్లో, దట్ ఆల్ కమ్స్ ఫ్రమ్ ఆర్డర్ ఆఫ్ ది రియాక్షన్. ఓకే. కొంచెం క్లారిటీ వచ్చింది అనుకుంటున్నాను నేనైతే. ఓకే. రైట్. లెట్స్ మూవ్ ఫార్వర్డ్. Okay, characteristics of order of a reaction. So just see here, order of a reaction can be 0 also. Koni reaction ki 0 order అని ఉంటుంది. Order of that reaction is how much? It can be 0 also. It can be positive also. Positive. Okay. Like any whole number, it can be like 1, 2, 3, 4 like that. It can be 0 also. 0 or any whole number you can take. Next, it can be a fractional number also. It means half order. It can be 1/3 order, like this also it can be. It can even be a negative value also, negative with respect to the particular reactant. Overall order could be never be a negative. It means, let us say rate A plus B plus C is giving some product. Now how do you write a rate law for this? Rate law is nothing but K, rate law is equals to K to the power concentration of A to the power M, B to the power n and C to the power, like let us say O. Now order with respect to A is M, B is n, C is O I am writing now. So now what they are saying is, this M value can be 0, it can be 1, it can be 2, like that. The total sum can be also 0, 1, 2, 3. Okay. And this Mn can be like Mn O can be fractional values also, like 1/2, 2/2, like that also it can be. Okay. But what they are saying, the total sum never be negative. The overall order can never be negative. M plus n plus O can never be a negative value. It can never be a negative. What they are saying, the individual M can be a negative, but total sum cannot be a negative. అంటే ఒక రియాక్టెంట్ యొక్క కాన్సన్ట్రేషన్ అంటే ఆర్డర్ విత్ రెస్పెక్ట్ టు వన్ రియాక్టెంట్ కెన్ బి ఏ నెగిటివ్ వాల్యూ, బట్ ఓవరాల్ ఆర్డర్ ఆఫ్ ది రియాక్షన్ can never be a negative. That is what they are saying. Okay. Right. Let's move forward. Okay. So now for this particular reaction, if you observe, rate law is given in this manner. For this reaction, rate law is given as K into N2O5. And ఈ reaction ki, this is a reactant now. For this reaction, this is a reactant. So now what we know, in rate law, involvement of only reactants will be seen, not products. So that's why K into N2O5. Here it is 2 is there, but here it is 1 is written. So what you need to know here clearly that these coefficients may or may not be equals to the order. So order only comes from experiment. Okay. So decomposition of N2O5 is a first order reaction. What is it? 1 is there in a power 1 is there means order of that reaction becomes 1. So you can say this particular reaction as a first order reaction. Emanali first order reaction. Next. For this reaction they are asking about order. So how do you do? So you can write the rate law like this. Br minus, what are the reactants we have? Br minus, BrO3 and H plus. So you can write concentration of Br minus, concentration of bromate ion, concentration of H plus ion. Now if you observe, the order with respect to Br is 1, BrO3 minus is also 1, H plus is also 2. So overall sum is how much? 1 plus 2. It is 4. The overall order of that reaction is 4. Sir, ee values ela mari? No worries. They will say in the exam. What is the order with respect to AB? Like ఏమైతే రియాక్టెన్స్ ఇచ్చారో వాటి యొక్క ఆర్డర్ గురించి అయితే డైరెక్ట్గానైనా ఇస్తారు లేదా కొన్ని క్లూస్ డేటాస్ అయినా ఇస్తారు. వాటిని బట్టి మనం ఇది తీసుకోవాలి. ఓకే, హోప్ ఇట్ ఈస్ ఆల్సో క్లియర్, రైట్? యా, లెట్స్ మూవ్ ఫార్వర్డ్. Okay, so what I told you, there are two types of reaction. One is called elementary reaction, other one is called complex reaction. For the elementary reaction, so they are saying this reaction is an elementary reaction. It means that takes place in single step. So whatever the stoichiometric coefficients you are seeing for the elementary reaction, those becomes the order with respect to the reactants. Like what is the stoichiometric coefficient of H2? It is 1. So H2 to the power 1. And I2 is there. What is the stoichiometric coefficient? 1. So H2 to the power 1, I2 to the power 1. So 1 plus 1, 2. So the overall order of the reaction becomes 2. Like this, we can able to calculate the orders for elementary reaction just by looking at the coefficients. But for complex reaction, we cannot get in this theoretical way. It only comes from what? From the experimental data. Okay, right. Okay, so for a complex reaction, the reaction involves more than one step. So the order of that reaction is calculated experimentally. Okay, so this is the example. So these many steps are involved in the given reaction. E reaction lo inni steps involved in. How many steps? 3 steps are seen. Okay, so whenever there is multiple steps involved in the reaction, you can call it as complex reaction. E complex reactions ki manam order చూసి చెప్పలేం. We need to know the experimental data. So you just write order rate is equals to concentration of NO, concentration of H2. But their orders how much we cannot give directly by looking at this equation. So this 2 and here 1 comes from where? Experimental calculations. Okay, hope this is a basic way of understanding the chemical kinetics. So if you have attended the last 2 sessions, these are really helpful to understand the basics of chemical kinetics as of now. Okay, so now what you got to know, there are some factors affecting on a rate of a chemical reaction. What are those? Especially we discussed about concentration, right? Concentration, temperature, okay, surface area, all this like catalyst, all this will be there. They have some like effect on the rate of a reaction. Okay, and the remaining things we will discuss in the upcoming sessions. Okay, I hope you enjoyed this session. So thanks for watching. Stay connected with our NEET World YouTube channel. Thank you.